Everyone, welcome to Big Data Thoughts. Today we are going to talk about yet another low level API in Spark. Previously, we have spoken about two high level APIs, dataset, data frames, and we have also spoken about a low level API, RDD. And today is one of the low level APIs, which is distributed shared variables. So, let's look at what are those, when are they used, and everything about distributed shared variables. So let's get started. First of all, a very quick recap. So what does Spark offer in terms of APIs? So there are two sets, high level or structured APIs, low level, and second is low level APIs. So high level structured APIs are nothing but dataset data frames. They give us a higher level abstraction and make the programmer's life easy to code. Now when you want, so there are three of those: dataset, data frame, and SQL. And the second set of APIs is low level APIs, which give us more control over the way the data is stored, where it is physically stored. We can control that. If there are some legacy code which are there which we want to manipulate, we can use these. So we have already looked at RDDs. Let's look at distributed variables today. Okay. And like I said, what are the low level APIs? These two, RDD and distributed shared variables. And distributed shared variables are of two types. We will look at both broadcast and accumulators, and we will see why they are used. When to use? So it is when you cannot find something. For example, you want to have a very tight control on the physical data placement, like where the data is actually getting split and put on which node, worker node. How do you control that placement? Then you use it. You want to do some custom manipulations with your shared variables, or you want to maintain legacy code base which is already written using low level APIs. So these are the scenarios in which you would actually use a low level API. Otherwise, most of the time people prefer to use high level or structured APIs because they give you a lot of out of the box functionality and they are easier to use. Okay, so first of all, let us look at distributed variables. What are distributed variables? Now, distributed variables means whenever there are variables that you want to use in your user defined functions that have special properties. These variables have special properties when they are running on a cluster. So the variables that you want to use in your UDFs and they have special properties while they are running on the cluster, you can think of them as distributed variables. Basically, it's a shared variable because Spark works on distributed architecture. And when I say distributed architecture, your data is spread across different worker nodes, and then there are multiple tasks executing there are multiple tasks on each worker node which are executing in parallel. Now, there will be situations where you want to share certain common data like lookup tables, certain variables among those worker nodes and tasks, because that's the need of your program. So essentially you would need a variable which is distributed, which is accessible to all the worker node and tasks for wherever your program is executing. So that is where you need this special or distributed variables to access the value. Now there are two types of distributed variables: broadcast variables and accumulator. So we'll look at both of them one by one. First of all, let's look at broadcast variables. As the name suggests, broadcast means what? You are broadcasting some information so that it is accessible to everyone. When I say everyone, it's a distributed architecture, it's a distributed setup. So you have multiple physical nodes which are executing in your code in parallel. So look at it this way: it's a distributed cluster which has multiple worker nodes. Each worker node has multiple tasks, and you want to broadcast this variable to all of them. That's why the name is broadcast variable. These variables are a way to share immutable value efficiently around the cluster without encapsulating them in a function closure. Usually, how do we have these variables? We have it under a function closure. But here it is different. The scenario is different because it's a distributed setup, and I want to efficiently share these variables across the cluster, and I don't want to do it within a function closure. Also, these are immutable. It has to be immutable, right? because the purpose is to share that information. Just take a simple example of a lookup table. It's a lookup table, but of course we need to keep in mind that it cannot be like terabytes of data that we want to share as a broadcast table. No, that won't work, right? So essentially it is either, it's basically data which is smaller inside, not literally in GBs and TBs. It can be a lookup table though. In most of the cases we use this for these kind of scenarios of sharing lookup tables, because those are something which we just want the program to read, and like a immutable variable. So these are shared immutable variables, and they are cached on every machine in the cluster instead of serializing it with every single task. Going forward, I mean in this video we'll also talk about the disadvantage of this serialization, deserialization that we have to constantly do. It will have a performance hit. So we want something like a broadcast variable which is immutable and it is cached on every node, and that is where this immutable thing is extremely important, because we are caching this particular data or variable on every machine. Now if it is mutable, how do you sync across the cluster between different nodes? So it works best when it is immutable, because then you can have copies of it cached on every machine to access it. Now, why are broadcast variables better? This is very, very important to understand. So how would you normally use a variable in a driver node? So what would you do when you want to have a variable in the driver node which is inside task? Okay, how do you reference it? For example, in a map operation, there will be a variable inside a function closure, but this is not efficient. Specifically when we are talking about large variables like machine, in case of lookup tables or machine learning models, these are huge. When I say huge, it's not definitely not in terabytes, but still it is huge, right? So in that case, we do not want to share it as a variable, like a normal variable inside a function closure. That is where we want to use this. And what is the reason? The reason is when we are using a variable in a closure, what will happen? It must be deserialized on the worker nodes many times, because we will have multiple worker nodes. Whenever it is copied to a worker node, it has to be deserialized, and it has to be deserialized many times within that worker node, because on a single worker node you may have multiple tasks running in parallel, or whenever the tasks are running, they have to again deserialize this variable. So if this variable is getting used in multiple Spark actions and jobs, it will be resent to the workers with every job instead of sending it once, if we use it as a normal variable inside a function closure. That's the disadvantage because of which broadcast variables came in. They are not like normal variables. They are variables which are immutable and broadcasted, copied into the cache of every worker node. So there is no question of doing this entire deserialization multiple times for each task on the worker node. It's a very important point to remember, because that distinguishes how broadcast variables are more performance efficient, better than the normal variables. Now coming to accumulators. What are accumulators? We looked at broadcast variables, right? Now there is another type which is known as accumulators. Accumulators are a way of updating a value inside a variety of transformations, and then you propagate that value back to the driver node in an efficient and fault tolerant way. Usually accumulators are used for debugging purposes or to implement counters or sums. Why? Because here we are talking about updating a value. That's a big difference between broadcast variable and accumulators. Broadcast variables are immutable. Like I said, we create copies in cache of every worker node, and that's an important point for broadcast variables. But here accumulators can be updated, and that's the purpose of accumulators. We can update it, do multiple transformations, and we can send it back to the driver in a efficient and fault tolerant way. That is the reason they are used to implement counters. So simply like in our programs we use counters, right, where we increment the counter based on certain conditions. That is how accumulators can be thought of. They are like counters, but they are operating in a distributed setup. So these have to be updated and sent back to the driver so that everybody in the cluster knows about them. Now we are not operating in a single node setup. So it's not that your program is executing on one machine and it can just keep updating the counter and reading it back. The setup is different. It is distributed. So when we update, we have to send it back to the driver for other worker nodes to access it. So this is a very quick overview of lower level APIs, distributed variables, both broadcast and accumulator. I hope this has given you very quick synopsis of what both of them are and what is the difference and why do we use them. So thanks everyone for listening in. Please like, share and subscribe to the channel to get more interesting videos. Thank you.